Welcome all. This is the class of engineers. Let us make analysis about coplanar parallel forces. As introduction, the forces which are having their line of action parallel to each other are known as parallel forces. The two parallel forces will not intersect at a point. The resultant of two coplanar concurrent forces can be directly determined by the method of parallelogram of forces. This method, along with other methods for finding resultant of collinear and concurrent coplanar forces, will be discussed in earlier chapters. First, let's start by moment of forces. The moment of force, often called as a torque, it is a measure of the tendency of force to cause rotation about specific point or axis. It describes how effectively a force can create rotational motion. By definition, the moment of force about a point is defined as the product of the force and the perpendicular distance from the point to the line of action of the force. We have three key components of the moment of force. First one is the force. The force is the external push or pull applied to the body. Second one is a pivot or point of rotation, the point about which the forces attempt to produce rotation. Perpendicular distance. It is the shortest distance from the axis of rotation to the line of action of the force. Then, the direction of the moment depends on the direction of the force. We have clockwise moment, I consider it as negative. There is also counterclockwise moment, I consider it as positive moment. There is a principle of moment. For an object in equilibrium, the sum of all clockwise moment equal to the sum of all counterclockwise moment. Moment are applied on first one, simple machines, to calculate the force required to lift an object. Secondly, structural engineering, understanding the stresses in beams and columns. Third one, on vehicles, when you analyze wheel torque and stability. Fourth one, in sports, by evaluating swings in golf and baseball. After making an overview of moment of force, let us take one example as exercise. On this exercise, it's called the force of 100 Newton is acting at a point A as shown in figure below. Determine the moment of this force about 0 point. On this example, they give us a force of 100 Newton, which is perpendicular to the line OB, which is perpendicular line, which is distance. They passing at OX axis at 60 degrees at 3 meters distance. We have a triangle, like triangle OPC. They give us the distance OC, but we must find the distance OB, which is perpendicular to our force of 100 Newton. We are going to use trigonometric relations about sides of right triangle. We have opposite side which is opposed to the angle given. There is adjacent side which is the side which are with the angle given. There is also hypotenuse. We know sine of an angle will be equal to opposite side over hypotenuse. cosine of an angle, which will be equal adjacent side to hypotenuse. Tangent of an angle will be equal opposite side to the adjacent side. It means sine of an angle will be equal to OB over OC. Cosine angle will be equal to CB over OC. Tangent of an angle will be equal to OB over CB. Then for finding distance OB, we have to know sine over 60 will be equal to OB over OC, which means OB distance equal to OC times sine 60. Does it mean OB distance equal to 3 times 0.866? OB will be equal to 2.598 meter. Then we find the distance OB, which is perpendicular to the force of 100 Newton. We know that the moment of force is that force multiplied by the distance, perpendicular distance of that force. That is mean our moment of force will be equal to 100 times 2.598, which will be equal to 259.8 Newton meter. This is the first method of finding a moment of force. There is also a second method you should use to calculate this exercise. Let us finding moment of force by using second method. We know the convergent point is shown as C. The horizontal and the vertical component of force 100 Newton acting at C as shown in figure above. Remember, when you need to find horizontal component, we use cosine, and the vertical component we use sine. It means that the horizontal component will be 100 Newton times cosine over 60, which is equal to 50 Newton. But this force is passing through 0. It means there is no perpendicular distance on it. Hence, there is no moment of horizontal force. The vertical component will be equal to 100 Newton times sine 60, which is equal to 86.6 Newton. This force is acting vertically downward at C, which is perpendicular to the distance OC. OC is equal to 3 meters. It means then the moment of this force is equal to 86.6 times 3, which is equal to 259.8 Newton. This is the end of our course. Very nice exercise.